Okay, today is Saturday, October 22nd, and going to be looking at OSPF. And I see many implementations of OSPF, primarily in organizations that have the staff and the staff with the knowledge to be able to achieve within OSPF the exact requirements that they have. And it is an extremely robust um, routing protocol, and the capacity of OSPF is magical. And part of the magic with OSPF is that it is a completely open standard. And if there's anything that someone wants to learn and about OSPF, I mean, let me just grab a tab here and drag over. So if you're curious about RFC, I think it's 28. Is it 2865? I can't remember. Well, I'll just do this. RFC, OSPF, and 2328. Okay. There we go. It's version 2. And RFC, OSPF. I want to bring up another one here. And while I'm doing that, let me just make a little statement here. This is something I was advised that I need to do, and it's going to be posted on at the beginning of the YouTube page. Any of the information that I'm presenting here is as is. I'm providing no warranty as to whether the items expressed, implied, or statutory included, but not limited to, any warranties of merchantability or fitness to a particular purpose, or any warranty that the contents of this item will be error-free. This is my sandbox for studying, and it's there for that purpose specifically. So anything that's seen here is for my use. And you're welcome to view the contents and look at the contents and use them in a way that might be beneficial to you, but I provide no warranty of fact that everything I've done in these labs is 100% correct, because I'm oftentimes just kind of flying by the seat of my pants as I work through these. So it's very possible that I'll make incorrect and inaccurate statements, and it's good engineer always goes back and checks to make absolutely sure that what's been said by one engineer is indeed fact. It's not that we don't believe our colleagues, it's that for me, I learn best when I learn it on my own. And I can't say that everyone learns that way, but for me, if I hear someone say something, if I hear them say that there's this RFC out there for OSPF, and if you want to really dig into it and understand how OSPF works, then I could take their word for it, but it's probably to my benefit, and I've just proven this to myself. It's absolutely to my benefit to go dig in and explore it on my own. So a lot about OSPF is no, everything about OSPF is open. So in that, we can just kind of get started. I'm just going to hit a couple of the real high points. OSPF is classified as an interior gateway routing protocol, an IGP. This means that it distributes the routing information between routers belonging to a single autonomous system. The OSPF protocol is based on the SPF, or link state technology, which is a departure from Bellman Ford, which we saw back in RIP-NG and RIP. One of the key factors about OSPF is that each router in the database in that autonomous system has an exact copy of the routing routes. The database is identical on all routers, and it's as the process of each router then taking that database and determining its best paths to the destinations. So we're going to look at a lot of detail, and I'm not going to wade through this because this is good reading on your own. And with that, I'm going to go back over here. So in this lab, what we're going to have is routers 1, 2, and 3. Let me make this a little larger. And I've already configured the routers with the interfaces on the routers and loopback interfaces. And with that, we're going to configure multi-area OSPF. We're going to verify that the OSPF multi-area is functioning and operating correctly. We're going to create an OSPF virtual link, and we're going to do some summarization down here with this area 100 on those loopback interfaces, and we're going to generate a default route in OSPF, and also going to use Wireshark, and I think I'll just go ahead and start it right now. I'm going to use Wireshark because we want to see the OSPF messages and how those messages flow. So if we're going to capture those at the beginning, so I'll just say we'll do it between R1 and R2 with R1, and let that go ahead and come up and put that in the background. So once we have a couple of some capture time, I can actually stop this, because then there's a repeat of the material. So you see right now the only thing that's being passed back and forth is just the SLARP, which is this is just a serial interface protocol to make sure that the link is still up, and it's just sending keep alives. So we're going to put that just down here, drag that off to the side, and go into router 1 and just take a look at the interfaces. Show IP interface brief. So there's the serial interface is configured on router 1. We have a 10.1.12.1 network there on the serial 1/0. The serial 1/3, I've got it configured, but it's not, the interface is configured, but I don't have the connected over to router 3 at this point. What we'll be using that in probably the next lab. So the loopback interfaces that are configured, and notice all the interfaces are in the up and up state. Router 2, show IP interface brief. Again, all the interfaces are in the up and up state. Serial 1/0 is connecting down to R1. Serial 1/1 is connecting to R3. We'll have a loopback 2 on router 2. And look at the same interfaces on router, the interfaces on router 3. The serial 1/1 interface is in the up and up state. Again, that serial 1/3 is the interface is configured, but notice that it is administratively down and protocol down because I haven't actually done the wiring, the connectivity from router 1 to router 3, but it's just there for now. It will be used later. The loopback 3 interface up and up, and loopbacks 100 through 103 in the up and up state. And I think with that, it is pretty straightforward. I've already, let me do show run interface loopback 1. Okay, show run. Oh, wrong router. Let me move over to router 1. Show run interface loopback 1. Okay. And the reason I'm showing you this is by default we're going to see something interesting happen with these loopback interfaces, how they are reported in the routing table in terms of the subnet mask, and there's some activity, configuration activity that we can implement to actually change it to have those loopbacks reflect the network the way we actually want it to be reflected. So let's see, I think on router 1 I need to go in here real quick and do a description interface loopback 1 description engineering department. And I need to go over to router 2, show run interface loopback 2. Yep, I need to go in here also conft. So I haven't completed the configuration. I thought I was done, but not quite. So a little homework here that I need to finish up and just take a moment. Interface loopback 2, need to make this description marketing. And over to router 3. Okay, so now I've got those. Now I have those loopback interfaces with the appropriate description so that they an indication of who they are and what they're doing. And now we can move back to router 1 and we'll go ahead and get started with configuring the OSPF. And so we're going to go here, go into global configuration mode and kick off. This is OSPF for IPv4. So we get started, router, our options there. Here's the one we want for this for IPv4. OSPFv3 is for IPv3. We'll be getting to that one in a little later. And we say OSPF and a process ID. And we're going to give this process ID 1. And the networks, so again, network. For the network for the segment between routers 1 and router 2, so let's say 10.1.12.0, and the wildcard mask for that 24-bit is 0.0.0.255, and then we indicate area. There's the area, and we're going to put this in area 0. First area has to be 0, and we have another network that we want participating in OSPF, and that's the loopback, the interface that's associated with loopback 1. So we're going to say network 10.1.1.0. Wildcard mask for that 24-bit is 0.0.0.255, area 0. Now if we go back over here, if we take a look already, you see as soon as the hello packets are already going out from OSPF, and the first hello packets started once the first network, that once this network here, this network 10.1.12.0 with that wildcard of 00.225 to area 0, let me go ahead and stop that. Once that network was confined, the first hello message started going out. And so we can look really quickly at this. Just want to look at we see the source is from 10.1.12.1, which we know is router 1. It's going to a multicast of 224.0.0.5. We've got the OSPF header here, that it is a version 2 OSPF. Message type hello. The OSPF router ID. Now notice here that the router ID that's been picked up already at this point is 172.30.30.1. Now that is loopback 30. Okay. Now what's interesting is that's not the actual router ID that we want to have. So we're going to actually define the router ID by itself. Now, did I define that, or is that a holdover from my previous? Okay, we'll just keep rolling. So there's the area ID, which is set up in a 32-bit format, 0.0.00. Hello packet, the network mask, designated router, backup designated router. Going to be covering both of those concepts, but not just at this point. So we've got the hello messages going out from router 1 to router 2, trying to look for anybody that wants to talk to it. And so now we're going to finish up here on router 1, and we're going to go into, we're going to say router ID 1.1.1.1, and can exit here, and we'll say interface loopback 1. Actually, I'm going to leave that for a moment. I was about to make a change here, and we're good. So we've got show IP protocols. We have a routing protocol is OSPF with process 1. The router ID is 1.1.1, and these are the networks that are currently participating. Routing for networks 10.1.1.0 and 10.1.12.0/24. And so we're good here on router 1. There's show IP route. Not receiving anything. We're only seeing our connected routes so far. So we're going to go ahead and just do a show IP OSPF. A little bit that scrolled off the screen, so I'm going to roll that up a bit. That, as a result of that show IP OSPF, we have the routing cross for OSPF1 with the router ID, the time that the process started, the time that has elapsed since the process began, more details. Let's see, rolling down further, that supports not so stubby, and the router is not originating router LSAs. We'll be covering what that means and what type of messages are associated with that. But we're just going to scroll, keep going down here till we get to that. We're talking about area 0, that it is inactive. So while this one it's been configured on router 1, it's not actually talking OSPF until there is a neighbor. Then it will be active. So let's go ahead and make this active and go over to router 2, go into global configuration mode, router OSPF1. Router ID 2.2.2.2, and networks 10.1.12.0, 0.0.0.255, area 0. Network. Okay, so we see that we've already gone from loading to full. Now if we go back to router 1 real quick and do that show IP OSPF again, you notice that before it said that the area backbone 0 was inactive. Now it says that the area backbone is 0. So we now have an adjacency change on router 2 and an adjacency change on router 1. So now if I do show IP route, no routes yet, because the only network that's been defined is a network that is the segment between router 1 and router 2. So we're going to define the loopback 10. Network 10.1.2.0, 0.0.0.255, area 0. And now if I come back to router 1 real quick, look at the route. We've actually learned our first OSPF route right there. where it learned about the 10.1.2.1/32, but notice it's showing it as a 32-bit. When I configured, if we go back to the loopback interface for router 2, we said that interface, if I do a show run interface loopback 2, I configured that with a 24-bit subnet mask. However, it is coming in and being processed in OSPF as a 32-bit mask. And what we have to make the change is we need to go into the interface loopback 2, and we have to issue a command that says that IP OSPF network, and that it is a point-to-point network. Now if I come back here to router 1, issue that command. Let me do a clear IP OSPF process. So we can bounce that, there we go, and route. See, now this has changed. Oh, we still haven't, waiting for the route. There we go. Now look, instead of it showing that 10.1.2.0 with a 32-bit mask, it's now showing it with a 24-bit mask, and this is very important. So all accomplished by changing the network type for that interface. Let's see, and I think we're done. We can do the same commands and do a write here because we have OSPF running. Do a show IP OSPF. And again, we see the routing process OSPF1 with router ID of 2.2.2 and working for area backbone 0. Number of interfaces in this area is 2, so that's the loopback interface as well as the interface for the segment between router 1. Area has no authentication. We'll be doing authentication in a later segment. And we'll also be digging a little more into the LSA types and some of the additional features in here in that show IP OSPF. So since we have an adjacency and neighbor here, let's do show IP OSPF neighbor. Whoops. Show IP OSPF neighbor. And we see our neighbor ID there. Our neighbor is neighbor 1.1.1. Priority 0. State is full, meaning that the database calculations are complete and the appropriate entries are now in the routing table. Here's the dead timer and the address for that neighbor and the interface. Okay, and we'll go, let's get the same information over here on router 1, show IP OSPF neighbor. We see that the neighbor is 2.2.2, priority of 0, state full, dead timer, the address, and the serial interface there is serial 1/0. That's the interface that's actually being used to for this segment. So seeing that show output there from the show IP OSPF neighbor, we went through the details there. Let's do a show IP route, and we see that we have that one route so far that's been learned on router 1, and we have one route going back to router 2, show IP route. We have one route that's been learned, and again, if we go back and look, I'm fairly certain we defined that 10.1.1.1 network with a 24-bit subnet mask. However, it's coming across in OSPF as a 32-bit. So let's go over here and go back in global configuration mode, and that is interface. Don't need to be all the way up there. That's probably enough. And that smaller. Yeah. And that's interface loopback 1. And we're going to say IP. What is happening here? Oh, I know what's wrong. There we go. IP OSPF. Right, I'm in the right place. OSPF. I want to look at the additional options subcommands here. We see we could actually go into where we're looking at a changing to a specific process ID. It's under here where we can work on configure the authentication on that interface. Cost, we can change the dead interval. We can change the hello interval. This message digest key would be used in connection with the authentication. But for this particular instance, we're going to be using the network command. And also we can actually shut down OSPF state to disable it under this current interface. So we're going to do those. We're going to say IP OSPF network, and we're going to define that interface for loopback 1 as a network type of point to point. Now if we go back to router 2 and look at the show IP route, and we just let's narrow it down and say show IP route OSPF. We only want to look at the routes that are part of the OSPF process. And now we see that the 10.1.0/24, whereas before it was 10.1.1.1/32. Okay, so we've got OSPF up and running between routers 1 and router 2, and now what we're going to do is jump on router 3, and I think we've looked at the show IP interface brief. Look at the interfaces real quick and go ahead and go into global configuration mode, router OSPF1 and router ID 3.3.3.3. Reason it's a good idea to set the router ID at the beginning. Actually, I'm not going to set it here. We'll see what happens if I don't set the router ID. I'm just going to leave it as it would. If right now, if I do show IP protocols, it says that the router ID is 192.168.103.1. Okay, it went to the highest loopback interface. So we're going to leave that, and I'll just go ahead and complete the network network statements 10.1.23.0, 0.0.0.255 for area 23. We're putting the segment between router, we're setting up a different area for on router 3. Okay, so that's area 23, and then we'll say network 10.1.3.0, 0.0.0.255 is the wildcard mask, and area 23. And we'll also go ahead and exit and go into the interface for loopback 3, and we'll say IP OSPF network point to point, so we get the correct subnet mask being transferred on that segment. And if we do end here and let's write this and show IP OSPF. So we see again that we are talking about the routing process ID of 1 with an ID of 192.168.103.1, and that the bandwidth is reference bandwidth unit is 100 megabits per second, and this is for area 23. Now next thing we need to do is, I can't remember. I think I actually, yeah. So I've configured router 3 for that for that network. But I need to go back up here to router 2. I know I was forgetting something. Need to go into router OSPF1 network. Bring up my notes. One of the things I've learned is when I'm working, it is important for me to have notes to work from, not to be completely verbose and have everything written down, but to have a starting point, because it's easy to get very lost very quick and forget the exact next step. So we're going to put that in. That's that 10.1.23.0 network, and I'm going to put that in area 23, and we should get, there we go. And now we've got our adjacency change with router 3. Now remember what I showed you, we were talking about if I come out here and I show IP protocol, oops, we see that the router ID here is 2.2.2. If we come over to router 3 and I say show IP protocol, we said that the router ID is 192.168.103.1, which is that's the highest loopback interface that's configured in the up and up state. So I actually want the router ID on router 3 to be 3.3.3.3. So I'm going to have to go back into the OSPF process and say router ID 3.3.3.3. Now watch what happens. Okay, it says reload OSPF, reload or use clear IP OSPF process command for this to take place. This is not something to do during production time. And why? Well, you'll see. I mean, you can kind of get the idea here. Reload automatic means that the router is taken offline and the iOS is reloaded, reloads the configuration, and the router starts over. So if that happens, all networking is down. So I'm going to just go say clear IP OSPF process and say yes. It happens very quickly here in GNS3 and in a lab environment. However, in production this could take a little longer, and it is an outage when that happens because we go down from full to down, neighbor down, interface down, or detached. Comes back up. I mean, we went from we were at 30, 36, 37, so we're talking microseconds here, but in production this could take longer, and it still is an outage, and outages have a cost, but we've gone back to full and full. So now if I say show IP protocol, we see that the router ID is indeed 3.3.3.3, which is the value that wanted it to have. Let's see, one of the things I want to take a look at, I'm actually going to, on router 3, I'm going to go back into OSPF. I'm going to go into router OSPF1 and go into, excellent, go into interface serial 1/1 and say IP OSPF shutdown. Okay, we see the neighborhood that neighbor adjacency is gone, and the reason I want to do that, I want to start another capture between router 3 and router 2, and because I want to capture, look at the details for this capture, and some of this is going to be helping in terms of looking at the type of message that are passed in OSPF. We see the hello message there. So I'm going to go back into router 3 and issue the no IP OSPF shutdown. Great, perfect. So we see a lot of detail here. We see database descriptions. We see LS requests, database description, LS updates, request updates, update, and then we're back to hello. So we're going to look at that information, those messages, and I think okay, so we've got that captured there, and I'm just going to minimize that for now and come back to router 3 and do a write memory to save our configuration, and we'll take a look at the show IP protocols and see that we're talking about OSPF process 1, and router ID is 3.3.3, and the networks that are routing for the networks that are listed here, the 10.1.3.0 network and the 10.1.23.0 network. If we do a show IP route, we have some, if we go up to the legend, IA stands for OSPF inter-area routes, and that is the routes that are from an area that are outside of another area. So router 3 is only in area 23, but because it has a neighbor relationship with router 2, it's learned about these routes that have the IA legend before it would for inter. IA stands for OSPF inter area. So we're learning more. The routing table is building, and what we're going to do now is let's see, let's take a look at the routing table on router 3. Show IP route. So we don't have the loopback interfaces from router 3. Remember that there's a show IP interface brief. We have all of those loopbacks, not that many, that are not participating in OSPF. So what we're going to do real quick is let's get them in, and we'll also make sure that we change the network type so that the appropriate subnet mask is sent along. So we're going to go router OSPF. Now we're going to go into interface loopback 3 IP OSPF network point to point, and we're going to say exit that network router OSPF1 network 10.1.3.0 0.0.0.255 area 23 interface loopback 100 network. I'm jumping ahead of myself. Router OSPF. My notes are incorrect here, so let me back up. Let's go back into the router process. Let's first get the networks for the loopback interfaces participating in OSPF, and then I'll change the network type to point so that the subnet mask is correctly reflected in the routing table. So we're back in the router process, and the next network that we want to get in here is the network. If we do real quick, do show IP interface brief. Okay, so we want to say network 10 dot, no, not 10, 192.168.100.0, 0.0.3.255, area 100. And now we need to go into each of the loopbacks. So we'll exit, interface loopback 100, IP OSPF network, point to point, interface loopback 101, point to point, interface loopback 102, IP OSPF network point to point, and the last one, interface loopback 103, IP OSPF network point to point. Okay, so if we exit here, do a right mem, and then we'll take a look at the OSPF, show IP OSPF, process ID, correct ID that we want for the, and that there are two networks, area 23 and area 100. We put the loopback interfaces in area 100. And if I do a show IP route, we see again we've got all of these. This is going to be part of our exercise to do a summary, because we don't want all of those showing up as separate entries in the routing table. That's not very efficient. So we'll keep doing a summary address. And I think what I want to do now is let's come over to router 1 and show IP route. What have we got in here? So we've got some inter-area routes that have been learned here. Also, we've learned about the 10.1.3, and we've learned about the 10.1.23. Okay, so there are times when we had a trading partner that needed to have access to the client's environment, but they didn't have an interface in area 0. And we know that, if I can bring it up real quick, let's see. Yeah, here we go. I mean, by definition, OSPF, all areas in open shortest path first AS system must be physically connected to the area backbone area 0. But there are cases where that's not physically possible. The partner is on another network. It's a company that's been acquired, and you want to use a band-aid approach to get their network, the two networks between the partner, the new acquisition, integrated. There's a way to do that, and that's using a virtual link, but it's considered a band-aid at best. It is not a situation that you want to keep in configuration in active configuration very long. You'd want to use this short term until actually the network redesign could be completed to actually integrate the new acquisition in a more sustainable going forward method. So what we're going to do is we're going to use the area 23 on router 3. And remember, if we do a show IP protocols, we have two additional areas on router 3. We have area 23 and area 100. So this is the networks for the new acquisition. And so what we can do is on router 3 we can actually set up what's called a virtual link. And let's take a look and get that done. Just COMP T, And it's really straightforward there, but there's a lot of mechanics going on behind the scene. And let's see, I want to stop that capture, and I want to start a capture. No, stop. Yeah. Start capture, and I want to capture router 3 HDLC, because we want to see how this virtual link appears coming across, and we'll have that as a capture that we can look back at. So that capture is running, and let's just go ahead and go in here and get that virtual link configured. So we say go back into the OSPF process, router OSPF1, area 23, virtual link, and the I'm doing it on the wrong router. I need to go up here to router 2 first. Let's do it from that side. Global config, router OSPF1, area 23, virtual link, and we're doing the virtual link to the router ID, which is 3.3.3.3. And then we're going to do the same thing on router 3. We're already there, so we're going to say area 23, virtual link, and it's to router 2's router ID, 2.2.2.2. And I should have seen, there we go. So we've got the adjacency change there for process 1 for the neighbor at 2.2 OSPF virtual link, loading and to full. And if we do a show IP route, okay, do show IP protocols. Anything looking different so far? Nothing really? Not really. Well, let's go back to router 2. Create memory. And let's take a look and say show IP route. Now our routing table has changed. We're now seeing, we see the enter. If I go back up, before our router table on router 2, we only had the 10.1.1.0 network, which was from router 1. However, now we're seeing enter area, OSPF enter area. We see those 100, 101, 102, and 103, and we'll also note those are coming in because of the virtual link. And what we're going to do is go to router 2 and say show IP OSPF neighbor. Okay, now we see that we have the virtual link interface. At first it's like, well, you're seeing that I'm seeing the neighbor twice. I'm seeing the network ID of 3.3.3. I'm seeing it twice, but it's important to just keep following the logic of the line, because this first one is for the virtual link. And so for neighbor, the neighbor is with the ID of 3.3.3. State is full. That's the address for the interface, and that's an OSPF virtual link. And the other neighbor is router 1, and then this is the router, the IP, this is the other neighbor relationship with router 3. Okay, which was within the formed on the 10.1.23.0 subnet. Okay, so we're good there. And I think the last thing we need to do, there are two more things, maybe no, one more thing, is to make this clean up the routing table so that it's a little more efficient, because we do not need on router 1 show IP route. We do not need all 3 of those addresses appearing in the routing table on both of these routers. We can actually have a summary address in the OSPF process for this area border router, which is what router 3 is, and we can actually summarize those networks, and we can optimize that routing table on routers 1 and 2 by having the summary sent out by the area border router. So here we're going to exit out, and we would say router OSPF1 area, it's area 100, because that's where the loopback interface is. Those loopback 101, 102, 100, 102, 101, 102, 103 are in area 100. Look at the options here. Range, summarize routes, matching address, mask, border routers only. Very important there. Only on the border routers will this work. And we're going to say 192.168.100.0, 255.255.252.0. And if we go back here, that's already changed. It may take a moment. Yep, there we go. So now we have a much more efficient routing table because of doing a summary on router 3. So we're saying that for any of the networks on this 192.168.100.0/22 subnet, this is the path to get them through serial.1/1. So instead of having this multiple entries as we had previously, a lot cleaner, we have one entry that's telling us where we need to go. Should see the same thing back here on router 1, show IP route. Again, we have a much cleaner entry, single line entry for those routes having been summarized. And I think let's do a show IP OSPF database. This gets into some of the details of the types of messages. So far, we know that router 1 has one neighbor that it has formed an adjacency, a relationship with, and that's router 2. So we see we're getting we have summary link states, and we have router states, area 0. And we're going to be going really deep into this because I actually start that in the next session. We want to talk about what this database, what the importance of this database, and what the information in the database, how it can be used to determine exactly what neighbors we have and how those neighbors are transmitting and the relationships we have with those neighbors. So I think it is one last thing, which was that this loopback 30 interface on router 1 was to be simulated as our internet connection. So we need to now have this network need the router, the OSPF process to let router 2 know that there is a default information, a different path, because right now router 2 says doesn't have any default paths. It's going to look into its routing table. So we want for internet activity, anything that doesn't have a designated path, we want router 1 to be that path. So let's go back over here. I'm going to say router 1 and to global configuration mode, router OSPF1, and it's pretty simple. Default information. I've seen this before. It was used in ripng, very similar command. We're going to say default information originate. Now if we go to router 2 and say show IP route, it may take a moment. See, can we ping from router 3 over to okay, let's see, can we ping from router 3 over to forgot to write that change on router 1, jumping around a little bit here. So let's do show IP in 3, and this loopback 30 is to be our network to simulate our network connectivity. So can I now ping that network from router 3? And so far I cannot. So now what happened here? I should have that route and should have pathway from router 3 to that loopback interface on router 3. Oh, I know what happened. If I do show run section OSPF, I think I forgot to put the full command. I only put default information originate. I need to have default information originate always. So I'm already in the router OSPF process here. So to play it safe, I'm going to say no default information originate, and then say default information originate, and there's another option, always. Okay, we can end it there. So now show our routing table. Oh, there we go. Now we have this E2, this OSPF, this E2, which up here in our legend says that this is an OSPF external type 2. And so we now have a default path. Should also see this on, I don't know why I didn't catch that when I was looking at router 2. Router 2 didn't have the default path. Now if I type it, router 2 now has a default path. Router 2, can we now ping 170, what is it? Can we ping, slow down. Can we ping 172.30.30.1? It's been a long day. Yay, success. So router 2 now has access to this network that we're simulating as our internet. So router 3 ping.172.30.30.1. Okay, now we have the connectivity that we wanted. So this is just, a very simple OSPF implementation. There's not a lot of major bells and whistles, but the magic of what's occurring is in the message types that are being transmitted behind the scenes, which I've captured, and we'll be looking at those captures. I'll do an entire session just on the captures, and I think that's a good place Now that we have the full connectivity from router 3, 3 to router 1, and router 2 to router 1, we have the E2 type, and we're going to play with that E2 type in another session.